Okay, so 1.2, this is basically going to be a section that talks about how to do a few things on the calculator. I think we're going to look mainly at what's called an intersection. We may have to adjust the window, like we learned yesterday as well. We're going to try to figure out where two different things cross each other. Okay, that's what I'll show you how to figure out. So anytime that you are solving a problem, it doesn't even have to be a math problem. These are just kind of some general tips to think about as you start to solve it. Okay, so what you want to do is make sure you read it. And usually when you read a problem, it's going to be two different things. One thing is going to be they're going to give you some information in the problem. And the other part is going to be, here's what you need to find. So you have to figure out what are you being given and what are you trying to find. Once you know what it is you want to find, we're going to figure out a way to find it. So in math, there's a few different ways that we solve problems. Generally, like with a word problem, if it said like the height of a building is 200 feet, somebody's standing 30 feet away, look up at the building at a 40-degree angle, that's a very visual kind of thing. So we'd probably want to draw it out. So sometimes drawing a picture is a good way to solve a problem. If I gave you something, this is a little bit more like statistics. Well, actually, it's more like counting. If I said to you, what are all the different ways you can arrange the letters A, B, and C? You might make a list. Now, that wouldn't be too bad because with A, B, and C, there's only 6 different ways you can arrange those letters. But if I said to you, tell me all the ways you could arrange the letters A through K, well, now there could be thousands or millions. So making a list isn't always practical if it gets too big. Another thing we might use is an equation. So if you were trying to figure out maybe the volume of a shape or the area, you'd look up an equation or a formula. Sometimes you have to make your own formula, and that's what we're going to do in our first example. So once you know what you need to find, and you decide, all right, I'm going to try this method, then you go ahead and do it. Okay, so now plug into the formula. Use your calculator to do the arithmetic out. Okay, that's the last step. All right, let's take a look. So in our problem, this is going to be about renting a car. And this particular company charges $15 to rent the car and 20 cents for every mile you drive. So if I wanted to know, all right, I'm going to rent a car, how much is it going to cost me? What would you need to know to figure that out? Yeah?
How many miles you plan on going?
Right, you'd have to know how many miles I drove it, and how many miles that I drove it is going to control what? That's going to dictate
The price.
the price. So there's really two things here that are coming up in this problem. One of them is how many miles you drove it, and the other one is the price. Generally, when we have a problem with two variables, we will use x and y. We're going to do some graphing, so it makes even more sense to use x and y. And we're going to talk about this a little bit later, but x is called your, bless you, independent. Okay, that's your independent variable. And y, that's called the dependent. And the way you can figure out which one is which is you ask yourself, well, does the cost depend on how many miles you drive, or does how many miles you drive depend on the cost? When you go to pay for the car, it's the first way. The cost depends on how many miles you drove the car. So the cost is dependent on the miles driven. Cost is dependent. Anything that depends on something else to figure it out is always the y variable. Any question on that? A lot of times money is a dependent variable, and money is controlled by maybe how many hours you worked or something like that. Money is often dependent. Okay, anyone think they could give me a formula starting out y equals that would represent $15 to rent a car plus 20 cents for every mile you drive? Yeah.
All right, so it'd be starting with y equals 0.20.
0.
X next to it.
0.20.
Just like that, plus 15.
Plus 15. Perfect. Okay, so they asked us to come up with that formula, and we did. Those were the directions. Write an equation to model the situation. Any questions on that? Now, let's see if we can use that formula to figure out the cost if we drive the car 50 miles. Okay, what would you do with the 50 and that formula to figure out the cost? Yeah, Jake?
Substitute it for x.
Substitute it for x, yep. So y equals 0. You really could just do 0.2 if you want. Times 50 plus 15. Right, now we use our calculator. What's 0.2 times 50?
10.
So 10 plus 15. 25. What is that? $25. Because that's how much it would cost. Now, how about we do 100 miles? Could we just say, oh, it's double the miles, double the cost? It's going to be $50. It's not going to be double the cost because you don't double the 15. Okay, the only part that's doubling here is the mileage. So let's plug that in. So y equals 0.2 times 50, or not 50, I'm sorry, times 100. Times 100 plus 15. Okay, and what does that come out to for a cost?
$35.
Yep, that's $35. So in both of those examples, we plugged in an amount of miles and we calculated the cost. Any question on that? So that formula that we came up with, that's called an algebraic representation of our problem. So in the book, if you see directions that say to come up with an algebraic representation for your problem, it basically means to come up with an equation. Algebraic usually means it's going to have a letter in it somewhere. You may have to define what letter you use. The book may tell you what letter. They may say, like, let A be the number of apples or something. You know, they may give you the letter. Now, we're going to do this problem. We're going to do it two different ways. I'm going to show you how to do it algebraically, and then we'll do it on the calculator. What's different about example 2 compared to the first two problems we did? This is different a little bit. Yeah,
We're getting the answer first.
Yeah, we're getting the answer for the amount of money, and we have to calculate the miles. So in the first two problems, it was really just arithmetic. This is algebra. Now we have to solve and get the variable alone. If we're going to solve it algebraically. And that's how we'll do it first. So if I have a cost of $50, where would that go in the formula? What letter is that going to go for, Ryan?
Y.
Yeah, that's going to go for y. Good. So y equals 0.2x plus 15. Okay, and now we solve for x. What would be my first step to get x by itself? Yep.
Me, right?
Ethan, yep.
Okay. Subtract 15 from both sides.
Okay, so we subtract 15 from both sides. Leads us to that step. And what would we do? This is the last step now. Yeah, Zach?
Would you divide 22 by both sides?
Yeah, we're going to divide both sides by 0.2. And we can use, again, you all got your calculators, so we can just use that. What's 35 divided by 0.2?
175.
Yep. So it's 175 miles. And that's how you solve it algebraically. I think in this case it's probably the fastest way to solve it. Now, let's look at a little bit different way that we can do it. Okay, I'm going to go back. Let's see. Let me. All right. So how are we going to do this algebraically? Well, we're going to go back to what we had at this step. I want to look at that, and I want to look at that. And what I'm going to do is I'm going to type both of those things into the calculator separately. And I'm going to graph them. So does anyone remember what button we press when we want to do some graphs? Yep. Press y equals. Okay, if you've got anything else that's still in there from yesterday, you can clear it out. So I don't have anything. And I'm going to type in 50. And I'm going to put that on y1. So we're going to put the left-hand side of this equation on y1. And we're going to put the right-hand side of the equation on y2. 0.2x, you don't need the 0. Just 0.2x plus 15. Now, the bottom one, that's a y equals mx plus b type equation. And what does that look like when you draw something in y equals mx plus b? Yep.
Usually just a slanted line.
Yeah, it's going to be a slanted line.
This one positive.
And the slope is positive. And what about the y-intercept? Yeah.
Just a horizontal line. Or no, it's just on the y-axis, right?
And what number would it be at?
It's gonna be at 50.
You should press it once.
So for the top one, it'll be at 50. How about the bottom?
Oh, 50.
15. So since we have a line with a y-intercept of 50, if I do zoom 6, is zoom 6 going to be a good zoom? No. What's the highest that zoom 6 goes? You want to remember, what's the top of the screen at when you do zoom 6? 10. Well, I need to go a lot higher than 10. I need to go all the way up to 50. And I don't even want the 50 right on the edge of the screen. So I'm going to go a little bit past 50. I would say for the highest, that's the y-max, I would put that maybe on like 60. That might be a good value. Now let's try that and see what we get. Okay, there's my line at y equals 50. But I can't really see what I'm looking for here. I'm looking for where this graph equals this graph. So visually, what do you think that means? If I'm looking for where two pictures equal each other.
You move it more right.
Yeah, I need to see where they intersect. Now, X was how many miles you drive. Does it make sense to drive negative 10 miles?
No.
No. In fact, the smallest number of miles you could really drive is 0. So it doesn't even make sense to look at negative miles. But we know we have to look at more miles than 10. We already know exactly how many miles we need to look for. All the way at 175. But let's say we didn't know. Maybe we try like 90. And we hit graph. Well, that's going to be better. We can see it getting closer, but it's not enough. So we keep adjusting the window till we finally figure out where they cross. Let's try 200. Hit graph. And we know that's going to work because we already know they cross at 175. Okay, so we can see it. We're definitely not going to try to sit here and count tick marks to figure out how far over it is. The calculator can tell us exactly where they cross. This is how you do it. So you press the second button, and then there's a button up at the top that says Calc. It's right above Tricks. So press second, Calc. And which option there do you think we're going to use? Yep, we're going to use intersect. So you can press 5. Once you press 5, the calculator is going to ask you 3 things. The first thing it's going to ask you for is to pick a point somewhere on the first line that you want to use. Doesn't matter where. You're just telling the calculator, I'm using the blue one. So all you have to do is just hit enter. The second thing it asks you for is a point on the other line that you're going to use. And they could be curved. In this case, they're not curved. They're just straight lines. It doesn't matter where you put it. You just have to make sure you hit enter somewhere on the red line. And then the third thing it'll ask you for is a guess. It doesn't have to be exact, but just try to move the cursor as close as you can. That's good enough. Just put it right there. Take your guess. And once you got it pretty close to where you want it, press enter for the third time. And it should give you a picture that looks just like that. Okay. How many people got an answer of 175? And it says intersection. Yep. Now, you might wonder, well, like, what would happen if you had a shape where there were 2 intersections? Okay, think of like a parabola and a line going like that. Now there's 2. You can do 2, but you have to do them one at a time. Okay? We're not going to worry about that right now, but that's where the guess becomes more important because the calculator only gives you one at a time. So we just put the guess near the one we want. In our case, the guess really didn't even matter. You have to do it, but it doesn't really matter. Yeah.
I got this grade.
All right, so let's try it one more time. So you're going to press second, Calc, and make sure you hit option 5. Make sure that when it comes up the first time, the font should be in blue at the bottom because you're picking a point on the blue line. When you hit enter the second time, it should now be red because you're picking a point on the red line. And the guess, you can put the guess anywhere you want. It doesn't really matter. Just hit enter, and that's what it should give you. It did it again?
Yeah.
Let's see.
Oh, good job. Okay,
So you want to make sure that when you look for the intersection, you do not want the intersection right on the edge of the screen. You always want to set your window to go a little bit past it. If you don't, that's what happens. So make sure whenever you're looking for something that it's kind of more away from the edge a little bit, and then it'll work. Okay, so that was the graphical approach. Any question on how to find an intersection point?
No.
Okay, so now, if I ask you on the test, find where the following two things cross each other, that's something I won't tell you if you're like, oh, I don't remember the button. You got to remember the button. You can write it down on a reference sheet. Second, calc, intersect. However you can remember it, you got to remember it. Now, when we first did this, we didn't have a good window. We couldn't see where they crossed. We always want to be able to see the important stuff in a graph. Well, what's the important stuff? Well, sometimes it's where two things cross. If it's a parabola, I would say, can you see where the bottom of the parabola is? So it depends on your graph. But once you have a screen that shows what's important, that's called a complete graph. All you have to do on the homework, if they ask you to find a complete graph, is take your window and write down, let me make that a little smaller. All you have to do is write down 4 values. Tell me the x, min, and max. That's part of what I need to know for the window. And the y, min, and max. Those are the only 4 things you have to write down when the directions say find a complete graph. And you can write them just like that. That's fine. So I think we did y equals x squared plus 10 yesterday. Did we do that one? Where I shifted it off the screen and we had to zoom up to find that it was a parabola shape. Okay, so we kind of already did that, so I'm not going to go through that one again. I'll just write down what we already used for a window yesterday. X min, X max, Y min, Y max. I think we set the Y max, we had to go higher. I think we set it to maybe 20. I think we did 20 to negative 20 on all of them. I think that's what we did. So negative 20 to 20 and negative 20 to 20. Bless you. That's not the only right answer, but I would say I would do negative 2 million to 2 million and negative 2 million to 2 million. I mean, if you zoom out that much, you're not even going to see it. It's going to look so small. You're not going to know what's there. So you got to find a reasonable window that lets you see what your graph should look like. But there isn't just one correct answer. Okay, that curve, I think we mentioned this yesterday too. That curve is called a parabola. That's a U shape. Parabolas can look like this, or they can look like that. They can open up, or they can open down. No, not a parabola. Nope.
What is a sideways parabola called?
It's going to look like a square root function. Well, half of a square root function.
I was going to say, you could put 2 square root functions.
Yeah, you'd have to do a plus and a minus to get a full parabola. I'm going to do just a half a parabola. All right, let's think a little bit about the square root. When you're dealing with real numbers, you can't take the square root of what kind of number? You can't do a negative, which means you want to make sure in this problem that whatever's underneath here is never a negative number. So if it's never a negative, then what do you want it to be?
Positive.
Or zero. Zero is fine. So we always want to make sure that that is greater than or equal to the number 0. We never want x plus 20 to come out to be negative. So what does that mean we want x to always be?
Negative 19.
Well, we want x to be, first we got to read that.
Greater than or equal to.
Greater than or equal to.
I think
negative 20. So we want it to be greater than or equal to negative 20. Now remember, that includes fractions and decimals. So you don't just want to say, well, then that means negative 19. No, it means negative 19.5, negative 19.6, negative 19.999. That's fine, as long as it's greater than negative 20. Okay. So the reason why we do that is because that's going to give us an idea of when we set our window up, what should the x min be. I don't want it to be right on the edge of the screen, so I'll go a little past negative 20, just so we can see it. All right, so how do you type in a square root? Well, first thing is you clear anything else you got in there. Type in second, and then it's the 5th button down on the left. Once you press second, and it'll give you a square root symbol. And we're going to put in x plus 20. Now, you never want to hit graph when you put something in. First thing you always want to do is check your what? You always got to check your window. All right, we know that we've got to go at least to we got to go as far as negative 20. We want to look at negative 20 and up. So let's go a little past. Let's do like negative 25. Now, you're going to see the square root function, it just keeps going. So there, you can go as high as you want with x. Like I could plug in 1,000,000 for x, and then add 20 to it, and take the square root of 1,020,000. X can keep going up forever. But we got to see how high y needs to go. Well, if x is 200, then I plug it in, because that's just what I have in there right now. So let's go with that. What's 200 plus 20? 220. And if you take the square root of 220, where are you at roughly? Pretty close to what number? A little bit lower. What's the square root of 220 roughly? You need your calculator.
Square root of 220? 55. Like 2 square root of 55.
Looking for a decimal.
You're looking for a decimal? 14.83239697.
Okay, so it's about 15. Because 15 times 15 is 225. We're looking for something times something that's 220. So 15 is roughly a good number for your y max. Now, I told you earlier, whenever you use that symbol for the square root, you're always looking for what kind of answer, unless they put another symbol in front. You're always looking for how do square roots always come out? Positive. The only times it comes out negative is if you put the negative symbol in front. Okay, so we're looking for a positive answer. Then it doesn't really even make sense to have y min at negative 10. You could put it on 0. I'll leave it on negative 10 so you can see it. But you really don't need to look that low because it's never going to be negative. Let's hit graph. And there's your square root function. And exactly what I said, it is half of a parabola. If you graph the negative part, it would give you the bottom. Bless you. But that's what square root functions pretty much look like. Any question on that? Bless you. So, find a complete graph. All right. This time, I'm just going to take my window. Sometimes when I drag it, the cursor messes up. Sometimes it doesn't. It didn't mess up there. I would write those down and write those down. And that's a good window. It shows exactly what it's supposed to look like. Any questions on that?
So a complete graph is just basically showing the graph in its entirety?
Yeah. I mean, this curve, obviously, it just keeps going, so you can't show it forever. But the important thing about a square root function is it starts somewhere and continues forever. If you cut the start off, that's not a complete graph. So if you do this, let's do zoom 6. Nope. To me, that doesn't look like a square root function at all. It almost looks like a straight line. Because I'm zoomed in so much now, I can't see the big picture. I had to zoom out a lot more to see what was really going on. And the start point, I know, was over here, and I cut it off. So that's a bad window for this function. Not good at all. Yeah. Okay. Any questions on that? All right, I'm going to pause because that's the first part. I'm going to let you write this down, and then I'll put the second part up. Okay, so from the first part, it's page 20, 6 through 10, 18, and 29. I'll make sure I put that on the board again with the second part. Okay, so the last thing we're going to look at is part of 1.3. And a lot of times we do end up breaking a section up into 2 pieces because we got about a half hour. Not enough time to finish it, but we'll start it. And 1.3 is on what's called a function. So let's look back at the rent-a-car equation that we had. This variable is your x, the one on the left-hand side is your y. And does anybody remember the name that I gave to the x? Independent. And the name I gave to the y? Dependent. There's also another name for x, and it begins with a D. Yep. Domain. And does anyone know the word that goes with that for the y?
Range.
The range. Yep. So we got most of them. We didn't do input output. So x is something you plug in a number for, you do a calculation, and then the output is the answer that you get from doing the calculation. So in this case, the output would be the cost. The input is how many miles you drove. Right? So if I was acting, like a computer and you said, well, how much is it going to cost? I'd say, well, you need to input to me how many miles you drove. Normally, I'd just say you need to tell me how many miles you drove. But the idea is input is something you plug in. Output is the answer you get. It's all just different names for the x and the y variables. Now, not everything that you draw on the calculator screen is a function. Okay, here's an example of something that is not a function. You don't have to draw this. You can just watch me do it. Okay, I'm going to set my window back to what we had. I think we had up to 200. And I don't remember if that was negative 25 or negative 30. It doesn't. That's okay. It goes off the screen a little, but I can still tell the shape. That's not a function. Does anybody remember there's a certain test that if you pass this test, you're a function? If you don't, you're not. Yeah?
A line test?
What kind of line?
Vertical line test?
Vertical. There's a horizontal line test. We'll talk about that later. Not today. But the vertical line test basically says if you can take a vertical line, you draw it, and it hits your graph more than once, it's not a function. So what does that really mean if you write it out? There's a point here, and there's another point here, where that vertical line is hitting that shape. Let's say this y value is maybe, I'm just going to estimate it, 1, 2, 3, 4, 5, 6, 7, maybe it's up around 7. This y value is maybe at like negative 7. Again, just a quick estimate. Now, how about the x value? I'm not really concerned with the number. But how does the x value that you put here compare to the x value that would go here? Yeah?
It'll be the same.
They would be the same, and that's the problem. If you can put a number here and you get two different answers for that number, that means your graph is not a function. So how do you say that? The idea is that if you pick an x value, there is only one y value connected to it. In that graph, that's not true. If you pick, I don't know, let's just make this up, maybe this x value is at like 20. If you plug in an x value of 20, you get two different y values, 7 and negative 7. You can't have that for it to be a function. It fails the vertical line test. So that's the definition of a function. Every single x value has exactly one y value.
Can you make that little box so I can see what's under it?
Yeah, what does it say under there?
F is in.
So it says a function f is an algebraic equation where every x value has one y value. Every input has one output.
Does a function f have any significance?
That's just the name. You can name functions using pretty much any letter you want. We're going to talk more about that notation in a second. But sometimes you might see a function called g, h. You can really name it any letter you want. So most people, when they think of a function, they just think of the vertical line test, which is exactly what that is. That's the vertical line test, but it's written out in words. I kind of already said this to you, so you really don't need to write that again. Domain, that's the x's, that's what you plug in. Range is the y, and that's the answer you get when you do the calculation out, or in our problem, the cost to rent the car. Now, one thing I will mention is it says valid inputs. Think back to this problem. What did we say x had to be in this problem?
Greater than or equal to negative 20.
So greater than or equal to negative 20. Those are the numbers you're allowed to use. Why? What happens if you plug in negative 30? And what happens when you do the square root of a negative? Yeah, you get an imaginary. We're not dealing with that. So negative 30 would not be a valid number you could plug in. Okay? Only numbers negative 20 and up. So square roots are something you have to be a little careful with. With square roots, you have to think about what numbers you can plug in. Here's something else you'd have to be careful with. Y equals 8 divided by x. Whenever you divide and have a variable in the bottom, we have to make sure that we never have what number in the bottom?
0.
0. So in this case, you could plug in any number you wanted for x except
0.
0. Any number except x would be a valid input. What if I did this? What number can't you use now? Negative 1. So any number except negative 1 is a valid input. So those are the only two functions you have to be careful with. Functions that have square roots and functions that have variables in the bottom. Other than that, really everything you can plug in usually any number you want, except with those two. So I told you yesterday, we are working with real numbers. We're not getting into complex or imaginary numbers. For now. So earlier somebody said, well, does it matter if you use f as the name of the function? And I said, well, it's just a way you can name a function. This is how we talked about the function in the rent-a-car problem. Bless you. Before. This is another notation. Does anyone know how you pronounce this?
Of
F of x. Yep. Is that what you're going to say?
Yes.
Okay. So f of x is just another way to write a function, and it takes the place of the letter y. If it confuses you when you see it, then change it to a y. But that's called f of x notation. So let's look at this one. What did we say about square roots? The number under here cannot be negative, which means you want this to always be what? So it's not negative.
greater than or equal to 3.
Greater than or equal to what number?
0, just 3.
We want that to be greater than or equal to 0. But we want x to be greater than or equal to 3. That's your domain right there. Your domain is the numbers you are allowed to plug in for x. So when they ask you to find the domain, you just put down, I just usually do D for domain. And there you go. That's your domain. How do we do the range? The range is a little harder. What I usually do is I graph it on the calculator, and then I look at it. You guys already know what a square root function looks like. So you kind of have an idea of what the domain should be. Let's type in square root of x minus 3. I think a zoom 6 this time is going to be okay. You're going to definitely see where it starts. Okay, so there's your picture. When we describe range, what letter is that again? Y. And how high is that square root function going to go? Remember, it's like a sideways parabola. Yeah, it never stops going up. It's just going to keep going kind of like this. It's going to keep going up. How low does it go?
0.
0. So how would you describe the range if it starts at 0 and it goes up forever? Exactly. The range is all numbers that are greater than or equal to 0. Yep.
Could that also be all real numbers?
It's not all real numbers because that would mean it goes down forever. This graph doesn't go down forever. It doesn't go anywhere down in quadrants 3 and 4. It only is in quadrant 1, so it's only from 0 up. And it said to find a complete graph. Well, I just did zoom 6, so that's the negative 10 to 10, negative 10 to 10, standard. And we did parabolas yesterday. I'm not worried about that one. Okay, let's look at this. So what does evaluate mean? Okay, evaluate means they give you a number to plug into a formula, and then you get the answer. So if you had a problem that says find f of 3, that means to take a 3, plug it in for the x, do it out, and then tell me what you get. So when you see the word evaluate, I'm looking for you most of the time to give me a number as an answer. Unless I don't give you a number to start with, then you won't get a number to finish with. Actually, I think we're gonna do that one. Yeah, let's try those. So I'll do them, I'm just going to put them right here. So plug in the x value that they give you for the variable, and then tell me what you get. And how did I get these numbers? I just made these up. So we'll start with -2. What's -2 squared?
4.
Plus 1?
5.
And that's how you evaluate this function for the number -2. Let's try 3. 3 squared plus 1? 10. So we started with numbers, we got a number. We start with a letter, we're going to end up with a letter. What would you get if you plug in a in that formula?
A squared.
Just a squared plus 1. You can't do anything with that. So that's what evaluate means. Any question on that? Did I have anything else? Nope, just more room to write the answers, but we already did. Okay, last thing. So we said earlier that not all equations are functions. And there was that sentence I gave you to describe it. When you plug in an answer for x, you get exactly how many answers for y? 1. Not 2, not 3, not 4, 1. Well, an easy way to remember that is called the vertical line test, which I think that's what I'm going to write down. Yep, right here. So this is a picture of something that's not a function. What does it look like? I already drew it for you. It looks kind of like a parabola on its side. It's the top half and the bottom half of the square root. How would you know to draw both halves? Plus or minus. If you take away the minus there, then this definitely is a function. Take away the bottom half, it's fine. Take away the top half, it's fine. But when you put the top and the bottom half together and make a sideways parabola, it's not a function. And it fails what's called the vertical line test. So vertical line test, very simple idea. If you draw a picture of something and a vertical line hits your picture more than once, then whatever you just drew is not a function. That's not a function. I can draw a vertical line, it hits more than once. How about circle? Is that a function? No. Because if I put in a vertical line, it hits more than once. We'll study more about that later on. That's called a sine wave or a cosine wave. Does a vertical line hit that more than once? No. No matter where I put that line, doesn't matter where you put it, it never hits more than once. How about a parabola? Function? Yeah. No matter where you put the line, it's always going to just hit one time. I know, it looks like my sides kind of curve in a little bit. They don't curve in. They just keep curving out. So that's the vertical line test. Any questions on that? Okay. All right, so let's edit this. Okay, so we had 6 through 10. 18 and 29. So you got about maybe six questions on the first page, and then probably 8 or 9 questions on the second page. What I'm also going to do is I'm going to pause the video. It's going to take me a minute, but I'm going to look at your test and I'm going to write down all the topics that we covered that are important. And if there's any formulas related to these topics, you may want to put them on your reference sheet. So I'll pause it and let me do the test topics.